Hello everyone, I am Amit Maru and today in this video we are going to discuss about quicksort algorithm. Quicksort algorithm is one example of a divide and conquer strategy. So let us discuss what is quicksort and how we can sort list of number into ascending order by using quicksort. As I said, a quicksort is a basically sorting algorithm to sort list of number into ascending order, and it uses the divide and conquer strategy. When we use divide and conquer strategy, as per the strategy of divide and conquer, we have to divide instance into different parts, right? So in this quicksort method, the division is dynamically carried out. There are certain steps that we need to follow when we use a quicksort algorithm. So the first step is first divide using pivot element. So when we start to divide our instance into different parts in our quicksort, we have to consider one element as a pivot element, and based on this pivot element we can divide our whole list of number into different parts. Then the second step is then recursively sort the subparts. Finally combine all the elements in a group to form a list of sorted elements. At the end of combining of subparts, comparison is not required. This is some steps that we need to follow when we sort list of number into ascending order by using quicksort. So let us understand a quicksort algorithm with one example so that you can easily understand the concept of quicksort. Suppose we have a list of number and total 8 number of elements are there, suppose. So initially, for example, we have to consider our first element as a pivot element. Here our first element is a 50. We have to consider as a pivot element. This is our first step. Step number 1, that we have to consider any element as a pivot element, but as per the rule we have to consider our first element as a pivot element. Then we have to find the proper position, or we can say the correct position of this pivot element in our list. Exactly when we sort the list of number into ascending order, at that time which is the correct position of 50. 50 is not one correct position right now, but we have to identify the correct position in this list, right? So that we have to consider our first element as a pivot element. So first element is a pivot element and pivot is equal to 50 in our case. Now we have to take another variable, for example I indicates the index value of our first element. The first element is 50 and index value is 0. So I is the index of first element, that is 0. We have to take another variable, for example j. J indicates index value of our last element. Our last element is 70 and index value is 7, so j is equal to 7. So I points our first element and j points our last element of the list, and pivot is nothing but first element, that is 50. Now the step number 2, that we have to move from left to right and right to left. For example, when we move from left to right, at that time we have to increase the value of I. Initially the value of I is equal to 0. If you want to move from 0 to 1, then we have to increase the value of I is equal to I plus 1. So the next value of I is equal to 1. It means that we will on second position. Then again increase the value of I, then we will get third element. Then increase the value of I, then we can get a fourth element. Likewise we have to move from left to right. When we move from left to right, at that time we have to identify the number which is larger than the pivot element. So for example, when we move from first position to the second position and the value is 30, 30 is not larger than the 50. Then we have to compare third element 10, 10 is not larger than the 50. Then we have to move from fourth element, and we have to check whether 90 is greater than the 50 or not. Yes, 90 is larger than the pivot element, so we have to stop there. So the last value of I is equal to 3, and this is our value which is larger than the pivot element. Again I am repeating, we have to move from left to right, increase the value of I every time, and we have to identify the number which is larger than the pivot element. So when we move from left to right, at that time our first element is 30. 30 is not larger than the pivot element. 10 is not larger than the pivot element, but 90 is larger than the pivot element. So here we have to stop, and the next value of I is equal to 3, and the value on that index is 90. Now, same way we have to move from right to left also. That is, right to left means first j is equal to 7. Then we have to decrease the value of j. J is equal to j minus 1, then 6. We have to decrease the value of j. J is equal to j minus 1, then 5 likewise. When we move from right to left, at that time we have to identify the number which is less than or is equal to pivot element. When we move from right to left, at that time we have to decrease the value of j and we have to identify the number which is less than or is equal to pivot element. So let us check, for example, the last element points by the j. So j is equal to 7 in this case and the value is 70. 70 is not less than or is equal to 50. So we have to reduce the value of j, and our next value, that is 40. So 40 is less than the pivot element. So we have to stop here and the value of j is equal to 6. Right? So the new value of I is equal to 3 and value of j is equal to 6. Right? Now we have to check the value of I and j. If the value of I is less than the value of j, here the value of I is equal to 3 and the value of j is equal to 6. Right? So now our next step is, if the value of I is less than the j, then swap both the values on index I and j. Here the value of I is equal to 3, value of j is equal to 6. So I is less than the j, condition is true, so that we have to swap index I, the value on index I and j. It means that we have to swap this both value 90 and 40. So 40 will be swapped here and 90 will be swapped here. Then we can get next a list like 40 will be here and 90 is here. Right? So now again we have to follow same step. We have to increase the value of I from left to right and we have to identify the number which is larger than the pivot element, and we have to move from right to left and identify the number which is less than or is equal to pivot element. So again repeat same step. Move from right to left to right, so increase the value of I. When we increase the value of I, our next value is 80. So 80 is larger than the pivot element, so our next value of I is equal to 80. And when we move from right to left, at that time we have to reduce the value of j and we have to identify the number which is less than the pivot element. So the 20 is less than the pivot element, so the next value of j will be this one. So the next value of I is this one and value of j will be this one. Now again we have to check the value of I is less than the j or not. Yes, the value of I is less than the j, so that we have to swap this both the value. Now swap this both the value, then we can get 20 here and 80 will be here. Okay, again we have to follow same step. We have to increase the value of I and identify the value which is larger than the 50. So our next value, that is 80 is larger than the 50, so our next I will be here. And move from right to left, then reduce the value of j and identify the number which is less than the pivot element. So the next value will be 20 and j will be here. So we can get like j is here and I is here. Now in this case the condition is false, I is not less than the j. In this case the I is greater than the j, the condition is false. When the value of I is cross the value of j, or we can say when the value of I is greater than the j, at that time we have to swap pivot element with the jth value on index j. Right? So value on index j is equal to 20 and the pivot element is 50, so we have to swap pivot with the jth element. So 20 will move here and 50 will move here. This is the last step. Here we have to check whether value of I is greater than j, so that a of j will swap with the pivot element and we can get middle position, that is position of 50. Right? So this is the swapping between pivot elements. So again I am repeating, when the value of I is less than the j, at that time we have to swap both the number only. But when the value of I is greater than the j, at that time we have to swap jth element with the pivot element. Right? So our next list will be like this. 20 will move here and 50 will move here. Now we can say our pivot element is on correct position. This is the correct position for the pivot element, and we are getting two part. First part that is in left part, and second part that is in right part. Now concentrate here, just see this list here. You can conclude that all the values which is left side the pivot is always less than the pivot element, and the number which is right part is always greater than the pivot element. Just check here 50, the value which is in left part is less than the 50. The 20, 30, 10 and 40 all are less than the 50, and the value in right part will be automatically larger than the 50. So 80, 90 and 70 will be larger than the 50. So it means that our pivot is on correct position. Right? Now same steps we have to follow for both these part. Now we have two different parts, that is the first part here and second part here. We are not going to touch now pivot element because it is on correct position. So we have to follow same step for this left part as well as right part. So let us follow same step for the left part first. This is the first part and this is our second part. So for this sub part we are applying our same steps. So we have to consider first element as a pivot element. This first element also indicates I, and last element also indicates J. So I point to first element, J point to the last element, and first element we are considering as a pivot element. So again we have to follow same step. We have to move from left to right, increase the value of I, and find out the value which is larger than the pivot element. So move from left to right. The second value is 30, so 30 is larger than the 20. So the next value of pivot, that is I is equal to 1. This is the 0th index, this is the first index, so the value of I is equal to 1. Likewise, we have to move from right to left. We have to reduce the value of J and identify the number which is less than or is equal to pivot. So 40 is larger, 10 is less than the 20 is pivot element, so the next value of J will be like 2. Right? So this is our I and this will be J in our next step. So this is I and this is our J. We have to check that I must be less than the J. Yes, the condition is true, I is less than the J. So we have to swap this both the number. So 20 will move here, 30 will move here. So 10 is here, 30 is here. Again we have to follow same step. We have to move from left to right and right to left. So increase the value of I, and our next value is 30. 30 is larger than the 20. So next value of I will be on this position. And we have to reduce value of J so that it will be 10, and 10 is less than the 20. So next value of J will be here. So the next value of I and J will be on this position and I will be in this position, so that we can say this I is not less than the J. The condition is false. The value of I cross the value of J. So that we cannot swap this both number, but we have to swap with our pivot element with the jth element. So jth element will be swapped with the pivot element. So the next list will be 10 will move here, 20 will move here, and we can get correct position of our pivot element. So now 20 is on correct position, 50 is on correct position, and we have a separate two parts. Left part which is less than the 20 and right part which is larger than the 20. Right, so now we have a separate two different parts. Now we have to apply same process for this portion, or we can say this sublist. So as we discussed, first element we have to consider as a pivot element. It is also in points by the index I, and the last element we are considering as a J in points to the last element. I point to the first element, and first element we are considering as a pivot element. Now as per these steps we have to move from left to right. When we move from left to right, at the time we have to identify the number which is larger than the pivot. So the 90 is larger than the pivot element. 90 is larger than the pivot element. So the next value of I will be on this position. Same time we have to reduce the value of J, and we have to check whether the number which is less than or is equal to pivot or not. So when we check 70 is less than the pivot, so J as it is. So I will be here and J as it is. So next value of I is on this position and value of J as it is, because 70 is less than the 80. Again we have to check this I is less than the j or not. Yes, I is less than the j, so that we have to swap this both the numbers. 70 will move here, 90 will move here. Then our next list will be like 70 here and 90 is here. Again we have to increase the value of I and identify the number which is larger than the pivot. So next value is 90. 90 is larger than the pivot, so the next value of I will be here. Next I will point to the last element, and we have to reduce the value of j, and we have to identify the number which is less than or is equal to pivot. So 90 is a larger, 70 is less than the 80, so the next value of j will be here. So j points to the 70 and I point to the last element 90. So the next position of I and j will be like this. In this case I cross the value of j, it means that I is not less than the j. So condition is a false, so that we have to move pivot element on the jth position, and jth position will move on the pivot element, right? So this 80 and 70 will be swap each other, and we can get a next list like 70 will be move here, 80 will move here, then 70, 80 and 90. Now 80 is on correct position. Right, now we have two separate part. One is 70 and the second part has only one element, that is 90. So only single part is there, so we cannot divide into different parts, and 90 cannot be divided into different parts because single elements are there. Likewise in this case also we cannot divide the 30 and 40, both are in the right part, but 30 is on correct position because 30 and 40, the 30 is minimum than the 40. If we try to divide, still we can get 30 on same position and 40 on same position, and this list is in ascending order. Right, so this is all about quicksort algorithm. I'm just conclude how quicksort algorithm runs. As per the quicksort algorithm, first step is we have to consider first element as a pivot element, then we have to move from left to right and identify the number which is larger than the pivot element, and this is our next position of our I. Same time we have to move from right to left and identify the number which is less than or is equal to pivot, and find out the new value of j. If the value of I is greater than the j, then we have to swap both the number. If this condition is true, then again we have to follow same step for next different values. Once the value of I is greater than the j, at that time we have to swap our jth element with the pivot element, and pivot will be on correct position. So in this way, every time we have to identify the correct position of every pivot, and at the end we will get list of number into ascending order, and this concept is known as quicksort algorithm. Let us have a pseudocode of quicksort algorithm. So as we discussed, quicksort is one function. We are passing one array which has a size n, 0 to n minus 1 array we are passing as argument. We have a two variable low and high. We can also use I and j in this case. So low indicates our first element, high indicates our last element. So low points to the first element and high points to the last element. If low less than high, it means that if more than one values are there in the list, if only one element, at the time no need to divide into different parts. If more than one values are there in the list, at the time we have to partition into different parts. So call partition function and pass the array list of elements as an argument. At that time first element will be considered as a low element and last element will be considered as a high element, and call this function partition. Now inside the partition function, first element as we discussed we are considering as a low element, and last element point by the high variable. Right? So in the partition, as we discussed in our quicksort algorithm, we have to first consider our first element as a pivot element. So a of low, it means that our first element. So first element we have to consider as a pivot element. Then we discussed that our first element must point by the variable I, and last value must point by the variable j. So take another variable I which points to our first element, that is a low index, and last index, that is high, So last element will be pointed by the j index. So I is the index of first element, j is the index of last element, and the first element we are considering as a pivot element. Now next step is we have to check every time the value of I less than the j, right? So every time we have to check the I less than j or not. Yes, when the value of I is less than j, then we have to move from left to right. When we move from the left to right, at that time we have to check the number which is larger than the pivot. If your number is not larger than the pivot, then this loop will be executed and every time we'll increase the value of I. Once we'll find the value which is greater than the pivot, at that time this loop will be stopped and we'll get a new value of I. In same time, we have to move from right to left and we have to identify the number which is less than or is equal to pivot element, right? So this loop will be executed until we get number which is larger or equal to the pivot element. Once we get less than or equal to pivot element, at that time we have to stop there and we have to identify the new value of j. So when we move from left to right, at that time we have to increase the value of I. When we move from right to left, at that time we have to decrease the value of j. Then after we have to check the value of I and j. If I less than j, then we have to swap a of I with a of j. When the value of I is not less than the j, when this condition is false, then we have to swap our pivot element with our jth element, right? So this is what we already discussed with one example that we have to follow to find out the correct position of pivot element. Now at the end we can get correct position of the pivot element, right? So then after same algorithm will be called. Once we get correct position of the pivot element, then we have to call same function for the first part and second part, because we are getting pivot element at the middle. So left part is always less than the pivot element and right part is always greater than the pivot element. So for the left part, which is starting from the low, and will be have a last element, that is m minus 1, and the second part is m plus 1 to the last element, right? So we have to recursively call this function for our both the sub part and continuously identify the pivot element, right? And every time we are getting pivot element on correct position, and at the end we can get list of number into ascending order. Now analysis of the quicksort algorithm. So as we discussed in divide and conquer, we can analyze any algorithm through the master theorem. So this is the equation of master theorem, in that we have to identify the value of a, b and f of n. So as we discussed in our quicksort algorithm, we are dividing into different two parts. So the b will be 2 and we are getting every time two parts. So the value of a is equal to 2. So a is equal to 2, b is equal to 2, and f of n is our n, that is a linear time. So to get the value n here, we have to put value k is equal to 1 and p is equal to 0. Put this all the value, a is equal to 2, b is equal to 2, k is equal to 1, p is equal to 0 in this equation, and based on the some condition of master theorem, we can get theta, that is t of n is equal to theta of n raised to log into b, log base b into a, log raised to p plus 1 into n. Solve this equation by putting value of a, b, k and p, then we can get a time complexity theta of n log n. So you know very well how we can find time complexity by using master theorem. So apply same master theorem here and find out the time complexity. You will get time complexity theta of n log n based on the master theorem. So this is the time complexity of quicksort algorithm. Thank you very much.